State the equation for torque provided by a force F applied a distance r from the axis of rotation. Oh, that's easy, right? Torque equals r cross F. So the force F, distance r from the axis of rotation, when you multiply these two, as long as they are perpendicular to each other, and if they're not perpendicular to each other, then you're just going to take the perpendicular component of your force by multiplying by F sine theta, you'll generate torque. For example, up here, the torque here has to be tau equals Fr sine theta, because these two are not exactly perpendicular to each other. What we need is the vertical component of that r vector. Or if you want to look at it differently, we need to break the force vector into a perpendicular component. But basically we need this piece of the triangle, however you want to get that piece. That's usually the easiest right there. So it's Rf sine theta, here shown with more accuracy, I suppose. And then here is the breaking down of the F vector, if you wanted to do that. Either way, as long as you have R and F that are perpendicular to each other, you will get a torque. Is it possible for a force to be applied but no torque result? Yes, of course. We talked about this extensively in the lesson. If there is no torque, you're just not rotating. Torque is the changing of an object's rotation, whether it's to start it rotating, stop it rotating, keep it rotating, any of that. That's what torque is, much like force is in the translational world. So if an object is translating but not rotating, translating but not rotating. Yeah. Is it possible for a torque to be applied to an object without the presence of an applied force? No! How can you have torque if you have no F? If you have zero F being applied, then you have no torque. Name a tool that best demonstrates the principle of torque. Explain how the tool is used to get more torque. I'm going to talk about two. Sorry, I had to pause to draw this octagon. Okay, let's pretend like that is a nut. Okay, and around the nut we have this perfectly matched wrench. You got the head of the wrench there, and then you have the handle. And the handle stops right there. No matter how much force we apply down here, and we're this distance away from the pivot point, let me draw in that R as yellow so that way you can barely see it. So we're that distance away and we're applying a downward force. That's going to generate a torque. If it's not enough torque to loosen up that nut, then we're going to have to do something or get a different tool. There is another tool that you can grab, which is called a torque wrench. And that torque wrench is the same idea as a wrench, but it extends the handle out, way out here, so it's a much longer handle. Another advantage to the torque wrench is it's actually calibrated to where you can apply a certain amount of torque as you're tightening up a nut. If you're working on a car, most pieces in your car have a set torque that needs to be applied. If you go too much, you could cause issues. If you go too little, it could fall out through the rattling. So make sure whenever you're doing repairs, you are following the recommended procedures. So a torque wrench, nice and easy name, and hopefully you can see what it does here. So I'm going to bring my line down here, and now we've got this big long arm, this big long lever arm. If we look at the arm, if we make this bigger, what's going to happen to the torque? It's going to be bigger, so that's going to make this a lot easier to loosen up this nut. Now, if that nut is still not cooperating with you, the second tool could come into play. And that second tool looks a little different. Instead of being cylinder like that, it's going to be a little bit bigger of a cylinder, like this. And what this thing is it's basically just PVC, a pipe. And that PVC pipe, sometimes it's called a plumber's helper. And what you do with that PVC pipe is you put it at the end of your wrench or your torque wrench. And look at what it does. It's going to extend out the lever arm even more. So now our lever arm is way out here. So again, we're increasing the R, which is going to make us able to generate more torque and apply less force while doing it. So if you have something stuck that you're trying to repair, give yourself an extra arm, extra length away from that pivot point.